SwayamPrabha. Digital India. Educated India.
Textile Processing Chemistry, lecture number 2. In this we will try to understand what are the different textile processing chemicals and what is their chemistry. Textile processing chemistry refers to the branch of chemistry that deals with the chemical processes involved in the production, treatment and finishing of textiles. It encompasses a wide range of chemical processes and technologies used in various stages of textile manufacturing, from fiber production to final fabric finishing. Some key aspects of textile processing chemistry include fiber preparation. Chemical treatments are often applied to raw fibers to improve their properties or make them suitable for further processing. This may involve processes such as scouring to remove impurities, bleaching to lighten the color, or dyeing to impart the color to the fibers. Dyeing and printing. Textiles are often dyed or printed to add color or patterns. Dyeing involves the application of colorants to textiles using various chemical processes, while printing involves applying colorants in specific patterns using techniques such as screen printing or digital printing. Textile processing involves finishing. Textile finishing involves various chemical treatments applied to the fabric after it has been woven or knitted to enhance its properties or improve its performance. This may include processes such as coating to add water repellency, flame retardancy or wrinkle resistance, as well as treatments to improve softness, smoothness or shine. Chemical auxiliaries. Textile processing often involves the use of various chemical auxiliaries such as surfactants, emulsifier, dispersants and thickeners to facilitate the processing and improve the performance of the textile treatments. Environmental consideration. With growth concern about the environmental sustainability, there is an increasing interest in developing textile processing methods that minimize environmental impact. This includes efforts to reduce water and energy consumption, minimize chemical usage and develop eco-friendly alternatives to traditional chemical treatments. Textile processing chemistry plays a crucial role. Textile processing chemistry plays a crucial role in the production of high quality textiles with desired properties and aesthetics, while also addressing environmental and sustainability concerns. The wastewater characteristic of textile effluent can vary widely depending on the factors as well as depending on textile processing chemicals, the type of textile production and the efficiency of wastewater treatment measures implemented by textile manufacturers. Effective management and treatment of textile effluent are essential to minimize its environmental impact and protect water resources and public health. Textile raw materials. The science of textile materials includes fibers and chemicals. Fibers are divided into two groups. Natural fibers include the protein fibers such as silk and wool, and cellulose and its related fibers such as cotton, linen, ramie and jute, plus certain other minor vegetable fibers derived from palm, banana, hemp, pineapple and coconut coir. Man-made fibers of natural origin are derived from cellulose such as rayon acetate and triacetate. However, the man-made fiber of synthetic origin are polyamides, that is nylons, polyacrylics and polyesters. These are produced by the polymerization of synthetic chemicals. Different types of textile materials. Textile raw materials are the basic fibers and substances used in the production of textile fabric and other textile products. These materials form the foundation of textile industry and are transformed through various processes into finished goods. Here are some of the common textile raw materials. Natural fibers. Cotton. Cotton is one of the most widely used natural fiber in the textile industry. It is derived from cotton plant seeds, hair, and is known for its softness, breathability and versatility. And all of us know that cotton, wool, silk, these are all natural fibers. There are new natural fibers which have been brought into the market, which are derived from pineapple leaves, from banana leaves, from hemp and coir of the coconut also. Wool. Wool is obtained from the fleece of sheep and other animals such as goats, alpacas and cashmere goats. It is valued for its warmth, moisture wicking properties and insulating qualities. Silk is a natural protein fiber produced by silkworms to form cocoons. It is known for its lustrous appearance, softness and smooth texture, making it suitable for luxury fabrics. Different natural and man-made fibers. Flax, which is linen. Flax fibers are derived from the stem of the flax plant. Linen made from the flax fiber is valued for its strength, durability and natural luster. Hemp. Hemp fibers are derived from Cannabis sativa plant. They are known for their strength, durability, sustainability, making hemp a versatile textile raw material. Man-made synthetic fibers, that is polyester. Polyester is a synthetic fiber which is a polymer widely used in textile production. It is known for its durability, wrinkle resistance and ability to retain shape and color. Nylon is another synthetic polymer fiber known for its strength, elasticity and abrasion resistance. It is commonly used in activewear, hosiery and industrial textile. Acrylic fibers are synthetic fibers made from polymers derived from petroleum or natural gas. They are valued for their softness, warmth and ability to mimic the properties of wool. So, we have both natural as well as man-made fibers, synthetic fibers, which are the prerequisites for any textile material formation. Different blends and specialty fibers are also there. Polypropylene. Polypropylene fiber are lightweight, moisture wicking and resistant to mold and mildew. They are commonly used for outdoor textiles, ropes and geotextiles. Rayon. Rayon is a semi-synthetic fiber made from regeneration cellulose fibers derived from wood pulp. It is known for its softness, drape and breathability, resembling natural fibers like cotton and silk. Blends. Textile manufacturers often create blends of natural and synthetic fibers to combine and get the desirable properties of each of these material. Common blend includes cotton polyester, wool acrylic or polyester viscose. So, either the textile manufacturer will use natural fiber or he will use synthetic fiber, or he can have a choice of using blends of natural and synthetic, which are enlisted here as cotton polyester, wool acrylic and polyester viscose. There are specialty fibers also. In addition to the traditional textile raw materials, there are also specialty fibers such as bamboo, soy and recycled fibers made from reclaimed materials. These fibers are often promoted for their sustainability and eco-friendly properties. Other unique fibers used are, there are just some of the primary textile raw materials which are mentioned just now used in the industry. The choice of raw material depends on factors such as intended use, desired properties of the fabric, availability, cost and sustainability considerations. In addition to the common natural and synthetic fibers mentioned earlier, there are several other fibers used in textile processing, each with its unique characteristic and application. Here are some of the examples. Bamboo fiber. Bamboo fiber is derived from bamboo plant and is valued for its softness, breathability and antibacterial properties. It is often blended with other fibers to create textile with enhanced comfort and sustainability. Soy fiber. Soy fiber is made from byproduct of soya bean processing. It is known for its softness, moisture wicking properties and sustainability. Soy fiber is often used in blends with other fibers for applications such as activewear and innerwear. So, you see that apart from natural fibers and synthetic fibers and their blends, there are other new types of fibers which have come into the market and they have their characteristic properties as well. Some of the other unique fibers are seaweed fiber. Seaweed fiber is also known as alginate fiber, is derived from seaweed or algae. It is valued for its natural moisture management properties, skin friendly attributes and sustainability. Seaweed fiber is used in textiles for clothing, bedding and medical applications. Milk fiber. Milk fiber is also known as casein fiber, is made from milk proteins. It is known for its softness, smoothness and moisture wicking properties. Milk fiber is often blended with other fibers to create textiles with a luxurious feel and enhanced performance. Lyocell. Lyocell is a type of regenerated cellulose fiber made from wood pulp. It is known for its softness, strength and biodegradability. Lyocell fibers are used in a variety of applications including clothing, home textiles and non-woven fabric. Some of the other unique fibers are corn fiber. Corn fiber, also known as ingeo, is a biopolymer fiber derived from corn starch. It is valued for its softness, moisture management properties and biodegradability. Corn fiber is used in textiles for apparel, bedding and hygiene products. Recycled fibers. Recycled fibers are made from reclaimed material such as post-consumer plastic bottles, industrial waste and textile scraps. These fibers are processed and spun into yarns from used for various textile applications. Recycled fibers help reduce waste and conserve natural resources. Hemp. Hemp fiber is derived from Cannabis sativa plant and is known for its strength, durability and sustainability. Hemp is used in textile for clothing accessories and home furnishing, offering a natural and eco-friendly alternative to conventional fibers. So, there are a variety of fibers which can be used. Nettle fiber. Nettle fiber is derived from the stalks of the stinging nettle plant. It is valued for its strength, durability and eco-friendly properties. Nettle fiber is used in textiles for clothing, upholstery and technical applications. These are just a few examples of the diverse range of fibers used in textile processing. As consumers' demand for sustainable and eco-friendly products grow, the use of alternative fibers derived from natural, renewable and biodegradable sources is also expected to increase in the textile industry. Chemicals that are used in textile processing, because in this chapter we are trying to understand the different textile processing chemicals or chemistry. So, having understood about the textiles, now let us see what are the chemicals that are being used. Large number of chemicals are used in textile processing due to two factors: those which are intended to remain on the fiber such as dyes and finishes, and those which are intended to wet or clean the fiber such as surface active agents or surfactants. Having a hydrophobic end and a hydrophilic end represented by Ry, where R is a long chain hydrocarbon and Y can be charged positively as quaternary ammonium NH4 plus or negatively COO minus, sulfate minus, phosphate minus or neutral moiety ethoxylates. So, there are many such surface active agents which are also used. Common chemicals used in textile processing. Textile processing involves various chemical substances to achieve different functions during the manufacturing. Some common chemicals used in textile processing include dyes and pigments, and as I told you that these chemicals that are enlisted here are used and are mandatory to be used for textile processing. One cannot omit them. So, dyes and chemicals have to be used, dyes and pigments. These are used for coloring textiles. Dyes are water soluble organic compounds that penetrate into the fiber, while pigments are insoluble particles that adhere to the surface. So, there is a difference between dyes and pigments, and this difference has to be understood very clearly. Dyes are soluble, pigments are insoluble, but they kind of adhere on the surface of the fabric. Auxiliaries, these are chemicals used to improve various aspects of textile processing such as softening, dye dispersion, anti-foaming and anti-static properties. Surfactants, these are used as wetting agents, emulsifiers and dispersant to aid in the penetration and dispersion of the dyes and chemicals in the textile substrate. Then there are bleaching agents. Chemicals such as hydrogen peroxide or sodium hypochlorite are used to remove natural colors from the fibers and to prepare them for dyeing. So, as we all know that grey fabric cannot be simply dyed directly. They need to be bleached in order to make it colorless, so that while dyeing the new colors adheres to the fabric. Fixing agent. These are used to enhance the fastness properties of dyed or printed textile, preventing the dyes from bleeding or fading during the washing or exposure to light. Finishing agents. These chemicals are applied to textile to impart specific characteristics such as softness, wrinkle resistance, water repellency, flame retardancy or antimicrobial properties. Solvents. Various solvents are used in textile processing for purposes such as dissolving dyes, cleaning equipment or removing contaminants. Alkalis and acids. These are used in processes such as desizing, removing sizing agents from the fibers, neutralization or pH adjustment during dyeing and finishing. So, each one has its own role to play. Textile auxiliaries. These include various chemicals like sequestering agents, leveling agents, anti-creasing agent, which assist in specific processes during textile manufacturing. Now, water and energy treatment chemicals. Chemicals are used to treat water used in textile processing to control pH, removal of impurities and reduce environmental impact. Energy saving chemicals may also be used to improve efficiency in processes such as dyeing or drying. It is important to note that the use of chemicals in textile processing has raised concerns regarding environmental and health impacts. Efforts are being made in many industries to develop and adopt more sustainable and eco-friendly alternatives. And just in the previous lecture, we saw that how these chemicals are used and have to be used, and how we can manipulate and treat the wastewater in the desired manner, recover some of the colorants and other chemicals for reuse and recycle the water by using different technologies. So, chemicals have to be used in textile processing, and therefore, textile effluent will get contaminated, but there are methods of decontaminating the textile effluent in a very economical manner. Types of chemical processing. Preparation. It is a group of wet chemical processes for the removal of all foreign matters from the fabric. This rendering, which is usually accomplished by washing with water and mild detergent, which is capable of emulsifying all the oils and waxes that are present in the grey cotton or grey material, or the starting material, or the woven material, which is now brought for dyeing and printing. Special scouring processes are necessary for cleaning the materials like silk and wool, since protein fibers are very sensitive to alkali and strong detergent. They are usually washed with sulfonated alcohols. Different type of textile processing. Textile processing involves a series of operations that convert raw fibers into finished textile product. Here are some of the common types of textile processing. Pre-treatment. This includes processes such as desizing, scouring and bleaching, which prepare the fibers or fabric for dyeing and finishing by removing impurities, natural oils and desizing. Dyeing. Dyeing is a process of imparting color to textile. There are various methods of dyeing, which includes direct dyeing, dyes directly applied to the fabric. Dispersed dyeing, used for synthetic fibers like polyester. Reactive dyeing, forms a covalent bond with the fiber. Wet dyeing involves reduction of dyes before application. Acid dyeing, used for protein fibers like wool and silk, and basic dyeing used for acrylic fibers. So, there are different methods, but one thing is for sure, that pre-treatment of the grey fabric is a must. After that, any of this dyeing method can be adapted depending on which type of the fabric is present and what needs to be dyed. Printing and finishing steps. Printing involves, in a textile, printing, design or patterns are applied to fabric using various techniques such as screen printing, which uses stencils used to apply dyes or pigments. Digital printing, which is direct printing from digital files. Rotary printing, continuous printing using engraved rollers. Block printing, design stamped onto fabric using blocks. So, there are many ways of doing printing: screen printing, digital printing, rotary printing, block printing, and there are n number of other such printing methods. Then comes finishing. After dyeing of printing, textiles undergo finishing processes to enhance their properties or appearance. Mechanical finishing, processed by brushing or sanding to create texture. Chemical finishing, treatment with chemicals to impart properties like softness, wrinkle resistance or water repellency. Heat setting, application of heat to stabilize fibers and improve dimensional stability. Calendering, smoothing and glossing the fabric surface using heated rollers. Embossing, creating raised or textured pattern on the fabric surface. Coating and lamination. Coating and laminating involves applying a layer of polymer or other materials to textile to add functionalities like waterproofing, flame resistance or insulation. Then comes the textile testing and quality control. It involves various tests to ensure the quality and performance of textile products, including tests for strength, color fastness and abrasion resistance and dimensional stability. Washing and finishing. After processing, textile may undergo washing and finishing operations to remove residual chemicals, improve softness and enhance appearance. These are some of the key types of textile processing. Each step is crucial in transforming raw material into finished textile products with desired characteristic and functionality. So, all this is done in order to make the grey material into a aesthetically admired material or aesthetically liked material, so that it can be changed into a garment. Now, let us again now look back at the textile processing. Mercerization is a special process which is applied only to cotton. The fabric or yarn is treated with strong sodium hydroxide solution as high as 20% while being held under tension. This process causes chemical and physical changes within the fiber, resulting in substantial increase in luster, smoothness of the fabric. This also improves dye affinity, stabilization, tensile strength and chemical reactivity of the material. What is meant by mercerization? Because let us understand, if it is a process which is particularly done for grey cotton, why is it done, how is it done, and what are the implications? Mercerization is a textile finishing process that improves the property of cotton fiber. Discovered by John Mercer in 1844, the process involves treating cotton yarn or fabric with caustic soda solution, usually sodium hydroxide 20%, under tension, typically at room temperature or slightly at elevated temperatures. The main effect of mercerization on cotton includes increased strength. Mercerization improves the strength of cotton fibers, making them more resistant to breaking or tearing. This is due to the swelling of the fibers during the process, which increases their molecular alignment and cohesion. Increased luster. Mercerization gives cotton fiber a smooth surface and increases the light reflectance, resulting in brighter and more lustrous appearance. Improved dye affinity. Mercerized cotton has enhanced dye affinity, allowing for deeper and more vibrant color absorption during dyeing processes. This results in textiles with richer and more consistent coloration. It also gives increased dimensional stability. Mercerization reduces cotton fibers' tendency to shrink or elongate when exposed to moisture or heat, improving the dimensional stability of finished textile. So, mercerization has many facets and many advantages that it adds to the cotton. Enhanced absorbency. While mercerization can reduce the porosity of the cotton fibers slightly, it generally maintains or improves their overall absorbency, making them suitable for a wide range of applications, including towels and apparel. So, if cotton towels are not mercerized, they will not have good absorbency. Overall, mercerization is a widely used process in the textile industry to enhance the appearance, strength, dyeability of cotton fibers, resulting in high quality and versatile textile products. Coloration of textile. And as what we learnt a little while ago, color can be imparted by two ways, by dyeing or printing. So, coloring of textile is accomplished by dyeing or printing. Dyeing consists of immersing the fabric or yarn in a solution of dye stuff, which in turn is attracted to the fiber and penetrates through it, thereby rendering colored fabric. Printing is, in contrast, it is done by use of pigments which are neither soluble in solution nor in fiber. They are simply deposited on the surface of the fabric, generally held by an insoluble binder. So, they are quite different processes. One is the dye is in solution. So, the solution impregnates into the fiber, whereas printing sits on the surface of the fabric. Coloration of the textile. Coloration of the textile refers to process of imparting color to textile fibers, yarns or fabrics. There are various methods of coloring textile, each of its own techniques and application. Some common methods of coloration include dyeing, and just a while ago we saw that how different dyeing methods are available. Direct dyeing. So, dyeing involves the application of dyes to textile materials to impart color. Dyes can be categorized based on their chemical properties and the type of fiber they are designed to color. Common dyeing methods are direct dyeing, reactive dyeing, dispersed dyeing, wet dyeing, acid dyeing. Direct dyeing is dyes directly applied to the fabric without the need of a mordant. Reactive dyeing, dyes from a chemical bond with the fibers, typically requiring the use of a reactive agent. Dispersed dyeing, used primarily for synthetic fibers like polyester, where dyes are dispersed in a carrier medium and applied under high temperature and pressure. Wet dyeing, dyes are first reduced to a soluble form and then oxidized in the fibers to form the insoluble pigments. Acid dyeing, used for protein based fibers like wool and silk, where dyes are applied in an acidic environment. So, you see in wet dyeing what happens is that there is a process where the dye is first made soluble by reducing, and then it is reoxidized on the fiber and then it sits on the fiber. Whereas in acid, where there is a proteinaceous material, we use glacial acetic acid or vinegar or some kind of an acidic medium. So, it makes the amides more susceptible, which are present in wool and silk, to take up the dye molecule. Different types of printing processes. We just discussed a few of them, but we will see in detail. Printing textile involves applying colorants in specific patterns or designs onto the fabric surface. Common printing methods include screen printing, a stencil based technique where color is forced through a fine mesh screen onto the fabric. Digital printing, direct printing from digital files onto fabric using specialized inkjet printers. Rotary printing, continuous printing using engraved rollers to apply colorants onto the fabric. Block printing, designs are stamped onto the fabric using wooden or metal blocks. Pigment printing, in this method pigments are applied to the fabric surface and fixed by using binders or cross linking agents. Pigment printing is commonly used for cotton and other cellulosic fibers. Special dyeing effects, that is dip dyeing or ombre effect. This technique involves immersing only a portion of the fabric into the dye bath, resulting in a gradient or ombre effect where the color fades from dark to light or vice versa. So, we have seen many such techniques in the fabrics that there are shades that are going from dark to light or light to dark, and so they are all giving a special effect of the dyed fabric, and they are dyed with by a special technique. Tie and dye, fabric is folded, twisted or tied in various patterns before dyeing, resulting in unique and colorful design. Bleaching and whitening. While not technically adding color, bleaching and whitening agents are used to remove natural color from the fiber or to create a white base for subsequent dyeing or printing. So, this is done prior to the dyeing or printing. These are just a few examples of the coloration method used in textile industry. Each method offers unique advantage and is chosen based on factors such as fiber type, desired color fastness, design complexity and production volume. So, these are just guidelines to tell you that these are the processes which are being used, but not all of them are used at the same time. It depends on the type of fabric, where it should be used and how it should be used, and the type of printing method that or dyeing method that it can undergo or should undergo. Now, let us look at some of the chemicals, that is the dye stuff. The choice of dye stuff depends on the physical and chemical nature of the fiber. Various types of dyes are used. Direct dyes. This dye is applied directly to cloth, usually low cost and easy to apply. Developed dyes. This dye is applied to the cloth and diazotized, and the color is developed with a secondary chemical called developer. Naphthol dyes. The naphthol is applied to the developer for coupling, thus producing further brightness in the color. Sulfur dyes. This type is put on the cloth in a reduced state and is then oxidized. Aniline black dyes. Aniline is oxidized on the fabric with air or steam aging. Vat dye. This dye is put on the fiber in its reduced state and is then oxidized, and one example of the vat dye is indigo. Other dyeing chemicals. Many other chemicals are used in dyeing process apart from dye stuff. They are used with an aim to increase the dye penetration, for color build-up gradually, thus ensuring uniformity. Other types of chemicals are migrating agents which help in dye molecules to move from one site to another within the fiber, thereby promoting uniformity. Penetrants may be surfactants of appropriate type which are mainly used in the case of polyester and are known as swelling agents. Retarders, agents by use of either a material or reverse charge or a non-ionic or both to form an unstable complex with the dye stuff. So, there are many reagents which have their own functionality and they are used for that purpose, and they have to be used for that purpose. Finishing. Finishing includes a group of mechanical and chemical operations which give the fabric its ultimate feel and performance characteristic. So, this is the last stage of the fabric processing. The fabric may be compressed to minimize shrinkage, or the surface may be polished or roughened. All these processes are mechanical operations. Many other desirable characteristics may be imparted to the fabric through the application of various finishing agents included as chemical operations. Chemical operations also include softeners, and they are used to give a desirable hand or feel to the fabric. These are chemicals which may be solubilizing groups such as cationic, non-ionic or rarely anionic, having a long fatty acid chain. In case of cellulosic fabric, various cross-linking agents are applied to react with cellulosic chain and impart resistance to shrinking and creasing. Other types of highly specialized treatment such as anti-static, antibacterial or soil repellent finishes may be applied to get special effect on the fabric. So, there are specialty treatments also, where you want to impart either flame retardancy on the fabric, or you want to impart antimicrobial activity or anti-static activity. These are special technical textiles which need to have these kind of properties. Such finishing operations and treatments are also possible and are being done. Mechanical operation. Finishes are usually applied by an operation known as padding, which consists of drawing fabric through a water solution of the chemical being applied, followed by passage through a set of squeezer roll which removes the excess liquid. A wetting agent or a penetrant is frequently included in this padding solution to help better penetration of the fabric. Sometimes the solution redirect sprayed on the fabric instead of padding to reduce the use of excess water. So, here some optimization of the water use can be also done. Same water can be, the one which has been squeezed out can be recycled and reused for this kind of property through the mechanical operation. Mechanical operation in textile processing play a crucial role in various stages of textile processing, from fiber preparation to fabric finishing. Here are some of the common mechanical operations involved in the textile processing. So, we were thinking that there is only chemical processing, but there are mechanical processing also which play a very crucial role in the textile processing. Opening and cleaning. Opening, this operation involves separation and loosening compressed fibers in raw material bales to prepare them for further processing. Cleaning, it involves removing impurities such as dust, dirt, seeds and short fibers from the raw material. Mechanical methods like air aspiration, carding and combing are often used in cleaning. Carding process. Carding is a process that aligns fibers in a parallel to form a thin web or sliver of fibers. It removes impurities and creates a more uniform and smooth fiber alignment, which is crucial for subsequent spinning processes. Mechanical processing also involves drawing. Drawing is a process of further aligning and stretching the carded fiber to improve uniformity and strength. It also blends fibers of different length to achieve desired characteristic in the yarn. Spinning is a process of twisting drawn fibers together to form yarn. Mechanical spinning method include ring spinning, open end spinning and rotor spinning, each offering different advantages in terms of yarn quality, productivity and cost. So, you see, both drawing and spinning, they have their own roles to play, and they are all mechanical processing of the fiber to make it into a fabric. Winding and wrapping. Winding involves transferring yarn from large packages into smaller ones for storage or for further processing. Warping is a process of arranging multiple yarn parallel to each other in the preparation of weaving. And you may have seen that in any textile material there are these bales which are prepared, and these single bales are then put in alignment, and then the fabric is woven because of the yarn coming from different bales. So, that is how these are all mechanical processes. Then comes weaving and knitting. Weaving involves interlacing warp and weft yarns to produce fabric. Mechanical operations in weaving include shedding, that is raising and lowering warp yarns, picking, inserting the weft yarn, beating up, forcing the weft yarn into place, and take up, winding the woven fabric into a cloth beam. So, it is a big process. It is not just simply that you think that two yarns come together and they can be woven just like that. It is a mechanical operation which requires this interlacing of warp and weft yarn, and once that is done, then they are picking up, then setting them, and then making them into a cloth. Knitting. Knitting is another process of interlocking loops of yarn to create fabric. Mechanical knitting machines use various mechanisms to form stitches, including warp knitting, weft knitting, and circular knitting. And this we see not only in woolens but also in hosiery materials. Finishing. Mechanical finishing operations include processes like calendering, which is smoothing and glossing the fabric surface, using heated rollers, shearing, removing excess fibers from the fabric surface, brushing, creating a softer texture, and raising, lifting surface fibers to create a fuzzy or napped effect. So, it is a long drawn process. Mechanical finishing not only uses calendering, which gives a smooth finishing and glossy look, but also it removes excess fiber from the fabric surface, brushing to remove all the fuzz that is created, the raising of the small bits of hair, and therefore, it is very important that these finishing processes are also done in the mechanical processing manner. So, to conclude, in conclusion, textile processing is a multifaceted and intricate series of operations that transform raw fibers into finished textile products. Throughout this process, various mechanical, chemical, physical techniques are employed to achieve desired characteristics such as color, strength, texture, and functionality. And we just now saw that how different chemicals can make a difference, and their uses are all strategically planned, because if a smooth finish has to be done, there has to be some kind of a smoothing agent. If the dye has to be done in a uniform manner, a dispersant has to be used. Surfactants and emulsifiers have their own role to play. So, every chemical and every mechanical process has its own significance in textile processing. Beginning with fiber preparation, mechanical operation such as opening, cleaning, carding, and drawing are utilized to refine and align the fibers. Chemical processings like bleaching, dyeing, and printing are then applied to impart color and other specific properties to the fibers or fabric. Mechanical processes such as spinning, weaving, knitting are employed to convert fibers into yarn and yarns into fabric, utilizing different techniques and machinery depending on the desired end product. Finally, the finishing operation such as calendering, shearing, brushing and raising are carried out to enhance the appearance, texture and performance of the fabric. So, in this chapter we have seen that what are the different types of textiles that are being used in textile industry. They are of two main categories, one is natural, the other one is synthetic. Among the natural, we looked into the different types of natural fibers like cotton, silk and wool. Apart from that, there were some new fabric which came into our knowledge, that is from bamboo, pineapple, hemp, linen, which are not now getting slowly popular, from coconut coir, and many such new materials have come. Then we saw about the dyes, different types of dyes that are being used for dyeing these different natural and synthetic materials. Because as you see, this chapter is dedicated to textile processing chemicals. So, we are trying to understand the chemical nature of all the components which go into the textile processing. And in order to understand that this textile processing requires firstly textiles, then dyes, and dyes and pigments are different because dyeing can also be done to the fabric and printing also can be done, and mostly pigments are used for printing and dyes are used for dyeing. Different types of categories of dyes we learnt in this chapter, in this lecture, and we understood that dyes, depending on the kind of fabric, need to be either a direct dye or a reactive dye or a dispersed dye, and therefore, we need to understand and know all the details of this wet dye as well as acid dyes. Then we went on to see the different types of chemical processes, and we saw in detail the process of mercerization and its importance for cotton. And therefore, we then moved on to the mechanical processing, and mechanical processing is also a part of textile processing, because here spinning, weaving, knitting and all these are were covered, so as to understand how we convert the fiber into yarn and the yarn into fabric. And finally, we looked at the finishing operations, because that is how the final fabric is prepared, and the operations such as calendering, shearing, brushing and removal of the fuzz is what is going to make a difference in the appearance, texture and performance of the fabric. So, with this we have come to an end of this lecture. Thank you.